In this section, we're going to look at the normal rule. It is also known as the empirical rule. The rule is related to the standard deviation. We assume the data is bell-shaped, then the normal rule states approximately 68% of the data will lie within one standard deviation of the mean. Approximately 95% of the data will lie within two standard deviations of the mean. And finally, approximately 99.7% of the data will lie within three standard deviations of the mean. Now, this is easy to understand if we have a picture. Here I am assuming the distribution is perfectly bell-shaped, so the mean is going to be in the center. The mean will be in the center. And if I have one standard deviation from the mean to the left and to the right, that means that's a total of 68%. So if I am within one standard deviation of the mean, that captures 68% of the people. Now if we look at two standard deviations, that means I'm going to add or subtract two standard deviations from the average. I will get 95% of the individuals will fall within that range. So if I take the average, add and subtract two standard deviations, 95% of the individuals will fall within that range. And lastly, if I take the average, add or subtract three standard deviations, that will capture 99.7% of individuals. So let's see how this works. Example. Assume that our class takes an exam and the average score was 72 and the standard deviation of the score was 8 points and the histogram of the scores was in fact bell-shaped. Then we can conclude the following. Roughly 68% of students scored between what and what on the exam. So we'll start by taking the average, which is 72, and we'll add and subtract the standard deviation, which was 8 points. I know the average is 72, and one standard deviation is 8 points. Again, the average is 72, and one standard deviation is 8 points. The average is always going to be in the center of our distribution, and I'm going to add 8 to this, so the average plus one standard deviation is going to be 72 plus 8, or 80. On the other side, we're going to subtract one standard deviation, and subtracting 72 minus 8, we get 64. Now I can answer the question. Roughly 68% of students score between 64 and 80. 68% of the students will score between 64 and 80 on the exam. For the next part, we want to know roughly 95% of the students score between what and what on the exam. So we'll go back to our picture again. For the next part, I want to have the mean in the center just like before, and I want to find what range of values will capture 95% of those exam scores. So we need two standard deviations. One standard deviation is 8 points, so two standard deviations will be double that, and that's 16 points. So I'm going to add and subtract 16 to 72. 72 minus 16 is 56. So I know two standard deviations to the left of 72 is 56. I know 72 plus 16 gives us 88. So two standard deviations above 72 is 88. Now we know roughly 95% of the students will score between a 56 and an 88 on the exam. For the last part, we want to find roughly 99.7% of students score between what and what on the exam. And we'll go back to the picture for the normal distribution again. Remember, the middle is always going to be our mean for a perfectly bell-shaped figure, and the mean was 72. One standard deviation was 8. Two standard deviations is double that 8, which is 16. So 3 standard deviation is triple that of 8, which is 24. So I want to calculate the range of values that would capture 99.7% of the exams, and that's within 3 standard deviations. 72 minus 24 will give us 3 standard deviations to the left of 72, and 72 minus 24 gives a score of 48. To look at the other side, we want to know 3 standard deviations above average, so we'll take the average mu and add 3 standard deviations to it. 72 plus 24 gives us 96. Now we know roughly 99.7% of students scored between 48 and 96 on the exam. Let's try another example. Given a data set comprised of 2,702 measurements that is bell-shaped with a mean of 901, it has a standard deviation of 51, what percentage of the data should lie between 748 and 901? Now I always want to write down the average first. The average in this case is 901. So the mean mu is 901. The standard deviation is given here as 51. And we want to find what percentage will lie within 7. And I want to find the percentage that would consist of the scores that are between 748 and 901. To do this, we'll go to our picture again. Remember, the mean is in the center, that's 901. And we have that the standard deviation is going to be 51. So what I like to do is I like to fill in the picture, and I will slowly go to the left and to the right by adding and subtracting a standard deviation of 51. So I'll go to the right first. The right of 901 is going to be 1 standard deviation away. So I'm going to take 901 and add 51 to it, and this gives us 952. For the next one, I'll just add another 51 because it's 2 standard deviations away, and this gives me 1003. And we'll add another standard deviation to get 3 standard deviations away. So add another 51, and we have 1054. I'll do the same method on the left, but we'll use subtraction. 901 minus 51 gives us 850. We'll subtract 51 again. I get 799. And the last time we'll subtract 51. This will give us 748. Now we can answer the question. What percentage of data should lie between 748 and 901? If you look at our numbers, this is 748 and this is 901. So I can add the areas between here and between here. So we'll take the percentages, 2.35% plus 13.5% plus the 34% to get our answer. 2.35% plus 13.5% plus 34% is going to give us our answer. And this adds up to 49.85%. Again, 49.85% of individuals scored between 748 and 901. I want you to pause the video and try these 3 problems on your own. First, I want to find out what the mean is. The mean in this case is 100. So we know mu is equal to 100, and the standard deviation is given to be 16. Before I start looking at the questions, I like to look at our picture and fill in the numbers. Remember, the mean is 100, so we'll put that in the center. That's just mu. And then we'll add 1 standard deviation to 100, which is 16. Our standard deviation was 16, and our average was 100. So 100 plus 16 gives us 116. I will continue to add 16 to get to the next section. 116 plus another 16 is 132. 132 plus 16 is 148. So just add 1 standard deviation to get to 116, add another one to get to 132, add another 16 to get to 148. On the left side, we'll have to do subtraction instead from the average. So we'll subtract 1 standard deviation. 100 minus 16 is 84. Subtract 16 again, I get to 68. Subtract 16 again, I get to 52. Now we can use this chart to answer the questions. Part A, what percentage of people has an IQ score between 52 and 148? So we'll go back to our picture and see. We have 52 down here and 148 here. So I know we're within 3 standard deviations, and the nice thing is I don't have to add up all of these percentages to calculate the percentage. The top here adds the entire region for me. So I know part A, the answer is 99.7%. Now we know that 99.7% of individuals have an IQ score between 52 and 148. Part B, what percentage of people has an IQ score less than 68 or greater than 132? Let's go back to our picture. I want to know those that are less than 68 or greater than 132. So I'll shade the region. We're going to go less than 68 and we're going to go greater than 132. So I could do this several different ways. I could add up 0.15, 2.35, and then add 2.35 and 0.15 to get the area. That is one way to do it. Another way would be just to do one side and then multiply by 2 since they're symmetric on both sides. And a third method would be to remember that all of these percentages should add up to 100%, and I can subtract the middle part that I don't want, which I know is 95%. So I can take 100% minus 95%, and there's our answer, 5%. So you could do it differently, but still get the same answer. Part B, what percentage of people has an IQ score less than 68 or greater than 132? We know that's 5%. Part C, what percentage of people has an IQ score greater than 116? For this problem, we'll look at the picture again. We know we want to find the area that's greater than 116, so we'll shade in the region that we want to add. I will have to add 13.5 plus 2.35 plus 0.15 to calculate our total area. And if you do the math, you get 16%. So we know 16% of individuals have an IQ score that's greater than 116. Now remember, this is not the only way to do it. You could have done it several different ways. Example, the weight of an organ in adult males has a bell-shaped distribution with a mean of 300 grams, and a standard deviation of 25 grams. Use the empirical rule to determine the following. I want you to pause the video and try it on your own. Use the picture and put in the numbers at the bottom and then calculate the percentages. Let's try the problem. I know the mean is 300 grams and the standard deviation is 25. Using these numbers, we'll fill in our picture. Recall the mean is 300 and the standard deviation is 25. We'll start with the mean, which is going to be in the middle, and then we'll add 25 to that. 300 plus 25 is 325. 325 plus another 25 is 350. And 350 plus another 25 is 375. So 3 standard deviations away from the average is 375. 300 minus 25 is 275. 275 minus 25 is 250. And 250 minus 25 is 225. In part A, I want to know about 68% of organs will be between what weights? If we look at our picture, we know 68% of organs are going to be between 275 grams and 325 grams. So for part A, we have our solution is between 275 and 325 grams. 68% of the organs will be between that weight range. For part B, we want to know what percentage of organs will weigh between 225 grams and 375. Between 225 and 375, so it's going to be this shaded region, all between up to here. So we can add all of these values if we wanted to, but it's a lot easier to look at the top and notice that they added it for us, and the total is 99.7%. We know 99.7% of organs are going to weigh between 225 and 375. Part C, what percentage of organs weigh less than 225 or more than 375? We want to know organs that weigh less than 225, this small region here, or greater than 375, this small region here. So we'll just add 0.15 plus 0.15, and that gives us 0.3%. So for part C, we know 0.3% of organs are going to be less than 225 grams or greater than 375 grams. Part D, what percentage of organs weigh between 250 grams and 375 grams? For part D, we're looking for between 250 all the way to 375 grams. So we can just add these percentages up to calculate our desired area. Adding up all the numbers, we will get 97.35%. 97.35% of organs are going to weigh from 250 grams all the way to 375 grams.